Hello all. In this video, we will be learning about the silicon controlled rectifier from the first unit power semiconductor devices. So previously we have learned generally about power semiconductor devices. We know very well that these devices will act as the electronic switches in power electronic circuits. The main purpose of these devices are to amplify the power supply, amplify the current or the voltage. So it mainly acts as a driver. It could act as a voltage driver and it could facilitate the power supply, and it could be used as a motor driver control. That is the main purpose. So it could be classified into three types. First one is uncontrolled power semiconductor devices, which could not be controlled at all. Semi-controlled power semiconductor devices, which could be partially controlled, turned on and turned off. Fully controlled semiconductor devices means it could be adjusted as per the necessity. So this is what we have learned previously. The next title is Silicon Controlled Rectifier SCR. So in BJT, we know very well that it will be having three layers in it. Two configurations were there in BJT, and in both the configurations, three layers were there. If we compare silicon control rectifier with the BJT, here we have four layers, PN and PN layers. So as like BJT, we have three layers, three terminals in silicon controlled rectifier. Here the terminals are named as anode, which is the positive terminal, cathode, which is the negative terminal, and gate, which is the common terminal. The only thing is the gate decides everything. When the gate is on, the silicon controlled rectifier will be turned on. When the gate is off, the silicon controlled rectifier will go off. So that is the main. So the main terminal is a gate terminal. So it could usually it could handle high voltage and high current. It could control the speed of the motor. So it could also act as a power converters. So these are the main applications of silicon controlled rectifier. So it acts as a solid switch. There are four layers in it. Two P layers are there. Two N layers are there. So as I mentioned already, P layers will be having so many holes in it. N layers will be having so many electrons, maximum of electrons in it. All the four layers will be connected to the three terminals. One is the anode, cathode, and the gate terminal. So intermediate junctions are called as J1, J2, and J3. So between the layers, between the P and N layer, there will be a junction. Again, between the N layer and the P layer, there will be a junction. Those junctions are called as J1, J2, and J3. So this is the image or the circuit symbol for anode, cathode, and gate. So here it is of four types. We have four types of silicon control rectifier. One is class A, class B, class C, class D, and class E. So class A is connected with the power supply resistor and the terminal. Class B is connected with the power supply, SCR, resistor, inductor, capacitor, and the SCR. So SCR is having three terminals in it. One is a gate, cathode, and the anode. So the main difference between class A and B is in class A we have only the resistor along with the SCR. But in class B, one inductor will be connected along with the capacitor and the SCR. So if we compare class C, the class C will be having two SCRs in it. Two SCR. When the application is quite bigger, if we want to control the speed of the motor, then we could go with class C, complementary commutation, silicon controlled rectifier. So class D, if we see class D, the resistor is connected along with the gate and a capacitor. If we see class E, two SCRs are there along with one capacitor, one resistor, and one power supply. So these are the types of silicon controlled rectifiers which we have. All are like triggering circuits. The main motive is to amplify the power supply, to control the speed of the motor, or to convert the power from AC to DC, These are the commutation circuits. The main difference is resistor in class A, resistor, inductor, capacitor RLC in class B, two SCRs to increase the effect, two SCRs in class C, one SCR, one capacitor alone, RC with a SCR. RC with the two SCRs. So that is main or easy way to remember the classes in silicon controlled rectifier. So here, as I mentioned already, these are the places where we will be using the SCR applications. So here we have the assessment question and the answer. And I hope you would have found the video to be useful. See you in the next video. Until then, it's bye bye from Radhika.